Hi, welcome to the intro video for our new unit, which is Unit 7 on similar figures. And in today's intro video, we're basically going to be covering just a couple of new vocabulary words. We're going to start first with talking about congruent, and then eventually we move on down here to similar. All right. Now for today's video, I just want to mention that our I can statement, I can identify corresponding sides and angles of two similar figures. So we're just trying to identify corresponding sides and angles. Now for this first symbol right here, this is actually the symbol that we use when things are equal in geometry. Now when I'm talking about equal, I want to point out here off to the side that we have seen this symbol before, and that just means the same. You could say that 8 equals 8. It works for a fraction. You could say a half equals a half. It works for decimals, like 0.3 equals 0.3. So we use this symbol in the world of math when things are equal. Now, if we're talking about shapes that are equal, all we do is put this little kind of squiggle on top of it. And now you know we're talking about shapes which are equal. So that's the symbol over here. And if shapes are congruent, then they have both the same shape, of course, and the same size. Here's an example right here, the red rectangles. Here we would say that this rectangle is congruent to this rectangle. So again, when you see this symbol in the world of math, it means the same, but we're just talking about shapes that are the same. You guys know that for these rectangles here, that the angles are all right angles. So if this is a 90-degree angle, this must also be a 90-degree angle. So R is the same as S. Now, as I'm writing my notes here, y'all, I'll mention that my symbols kind of suck. I just made that look a little bit like an inequality symbol. For the angle, it's technically supposed to look like that, but I'm going to be moving kind of quickly. And when I write it like that, it might just look like a less than symbol, but you guys know that I'm talking about an angle, okay? We know that A is a 90-degree angle, and that's in the same spot as angle N. So A lines up with angle N. I down here lines up with O. And N over here, this N lines up with this W. One thing that I want to point out here in this congruency statement is that it tells you like R should match up with S, and it does. A matches up with N, and so on. So you can use this thing over here to find the matching sides. Now in a rectangle, if I say that this happens to be an 8, that means over here, if they're the same, that this is also an 8. If I say that this is a 4, that means over here on this rectangle that these are both also a 4 because they're the same. That's what that symbol means. Now, just getting comfortable here with some formatting things. When you see line up above the two letters, it's talking about a side. So if you see this, it's talking about side RA. So side RA here is equal to side SN over here. So I'm going to put SN. And friendly reminder that I can use the fact that RA right here, it's the first two letters. So here's the first two letters SN. All right, for the first rectangle, A to I connects over here with N to O. So I'm going to put an NO. Don't forget to put the little line up above it because we're talking about side lengths. All right, I to N is down here on the bottom. So we're going to go from O to W. And N to R would be W to S. So we're just learning here how to match things up. And the matching up that we're doing right now, that's what I mean by this word corresponding. If they correspond, they match up, okay? Now this first example, once again, we're talking about shapes that are congruent. Congruent because they had the same shape and the same size. They were the exact same size. So if it's the exact same, we use the word congruent, okay? Congruent. And now down below, let's kind of explore the main part of what this unit's talking about. In this unit, we care less about if they're the exact same and more if they're similar. Similar is when they have, of course, that same shape, but now we're talking about different sizes. They have a different size. The angles are still going to be the same. The angles are going to be congruent. I'm going to explain what that means in a second. And the corresponding sides are proportional. So in the next part of the video, I'm actually going to talk about what all of this stuff means, and I'm just going to use this example down here. So in this example, we have this thing right here, and the way I read this, just so you guys know, this is in the language of algebra. I'm going to highlight it so it stands out. This thing in blue is in the language of algebra, and we're going to translate it now just simply into English. And all we're saying then is that triangle ABC is similar to triangle DEF. What that symbol means is that they're going to have the same shape, but they're just going to be different sizes. Now the angles are actually still going to be the same as each other. So the angles are still congruent. And what I mean by that, y'all, is if I take this and I trace angle B, it is the same as angle E right here. So the angles are still going to be the same. To prove it, if I gave you guys a rectangle, just because I take the rectangle and make it larger or smaller, the angles are still 4 90-degree angles. So the angles will never change. If you take a shape and make it bigger or smaller, the angle measurements should still be the same. For example, if I take this triangle right here, if I take this triangle and make it congruent, that's congruent. But now I can say similar by doing this. And similar will still have, let's see how that angle still fits right up in there. The angles are still the same. It doesn't matter if I want to make this similar shape smaller. Take a look. I'll make it smaller and see how that top angle still fits right there. So that's what we're saying when we're talking about congruency. We're talking about the fact that the angles are still the same here. The angles won't change. So angle A is in the same spot as angle D. So angle A down here is in the same spot as angle D, and that's what we're going to put right here. Angle B up here, B and E, and of course angle C and then F. Now in your notes, they should be in the packet. I'll point out that these little lines in here, that's how they match up corresponding angles. This has a little 1, and it matches with the one that has a 1. B up here, if you look closely in your packet, there's 2 little lines there. So that's how you know that those angles match up. And then again, in the world of geometry, we just say that this matches up with this one by putting 1, 2, 3 here. And that's what those little lines inside the shape mean. It tells you which ones match up. Now A to B over here, I can say, so my first 2 right here would be DE. And we can see it right here as well. If I highlight kind of this left side in yellow, A to B is the one that corresponds right here with D to E. So we're going to put DE right here. All right, now BC. So if I am in this smaller one, side B to C is over here. This is side BC. So that's going to be this side over here, E to F, E to F. And again, see how BC this time is the second 2 letters? So EF is the second 2 letters, and it matches up just like that. And last but not least here, we're talking about A to C. So the bottom side, A to C, or the A to C. So that's going to be D to F or D to F. So this thing over here is called a similarity statement. This is a similarity statement. It's just a statement that tells you that it's similar. And therefore, as long as you know how to read it, you can see the sides and angles all matching up because they're in the same spots. So again, to kind of summarize here, triangle ABC and DEF, they're called similar triangles because of course they have that same shape, but now they have a different size. Kind of like right here, these triangles, these are similar because they have the same shape, but they just have different sizes. Don't forget from the top part, if I copy and paste this rectangle, and it's the exact same one, it's congruent. So if it's the exact same thing, sorry about that, y'all. If it's the exact same thing, it's congruent. But the moment you make it larger or smaller, now it's similar. Okay? All right, cool. Let's flip over. And you should be at the top of the next page now, where again, this thing that I'm highlighting, I don't want you guys to forget that that thing is called a similarity statement. It tells you which angles match up and which sides match up. So if I use the similarity statement, you can see now that I might need it if I start to kind of turn the shapes around a little bit. So angle P right here is the same as angle T. So angle P here in red matches up with angle T here in red. Q is next, and then U is next. So Q is next here, and then U is next here. All right, we've got R, so R would be down here, and then the third one is V. So all I'm doing right now is just color coding and matching them up so that you can see, and then S and W go together. So we have an obtuse angle here, S, and then the obtuse angle right here, W. Okay. So now based on the color coding, we can see angle P goes with angle T. Angle Q goes with angle U. We said the R and V went together. And then S, the obtuse one, went with angle W. So for example, if I said that this obtuse angle over here, I'm just making this up, but let's just say this is like a 115-degree angle. If I say this is 115 degrees, then you know angle W is also 115 degrees. Okay? Just because the shape is a little bit smaller, the angles will still be the same. So what you can see I did was I simply took this shape and I basically flipped it and then made it a little bit smaller. Okay? Now PQ, so P to Q is right here, and that's T to U, so TU. All right, if we went from Q to R, we're going from this green to blue, so green to blue, so U to V. And again, you can see it works up here, QR, and then there's UV. All right, RS, we're going from blue to purple, so blue to purple, V to W. And then S to P, so purple to red, so right here, W to T. So notice it does matter if we're reading it from S up to P, I care that it's W up to T. Friendly reminder, we already put this on the other page, but our corresponding sides are proportional. And now I can actually, I'm just going to fill in some numbers to review what I mean by proportional, okay? So let's say up here, let's say for this side length, let's say I make this one a 20. And let's say I make this one an 18. Let's say this is a 16, or well, this one looks a little, this one should be the 18. Let's make this one the 16. Just looking at it, I'm totally making up some numbers here. And this one looks like the shortest of all. Let's just make this one, let's make this one a 10. Okay, so I just totally made up those numbers. Now, if these things are similar, and then I put a 10 over here, you see how it's like half the size? So this one would be an 8, half of that. The bottom here, half of the 18 would be a 9. And this side over here, half of that would be a 5. And when I say the corresponding sides are proportional, here's what I mean. I'm going to color this one green. So its corresponding side is green. And then let's let this one, I'll just make the bottom one. We'll just compare the top and bottom. How about if I let the bottom one be yellow? Here's the bottom one here. So all I'm saying, y'all, is if I go from green to green, I say I'm going from a 20 to a 10. And now the yellow 18 to 9. And when I set this up to make a proportion, we just want to see if this is true, yes or no. And you guys might remember we can cross multiply. I could do 20 times 9 and get 180. And 18 times 10 is also 180. So yes, they're proportional. Cross multiplying is one way. We can also recognize and see that if I do 20, cut it in half to 10, and 18 cuts in half to be a 9. So that's another way to prove they're proportional. We could also straight up divide and say 20 divided by 10 is a 2. And 18 divided by 10 is a 2. And since 2 equals 2, yes, they're proportional. So this is what I mean when I say that the corresponding sides are proportional. It doesn't matter which ones I pick. I could let this one be blue, which means this one's blue. And now I'm going to just quickly compare. Let's do green to blue. So green, once again, was 20 to 10. And now we're going to do blue. So 16 matches with an 8. And same thing. You could cross multiply. You could check for a scale factor. You could see that these both equal a 2. But once again, no matter which sets I take, the corresponding sides will form a proportion. All right, now we're ready to move on to example 4. You can see once again with these examples that if I start to kind of turn the shapes around, it's a little tougher to see what matches up. So that's why we use the similarity statement. Once again, it tells us T matches with G. So T here matches with G. And that makes sense because we can see that they're both 60 degrees. P matches with K. So here's my angle P. And that makes sense. That's my right angle matching with angle K. and then N and R. So here's my 30-degree angle N, and there's the 30-degree angle R. So we have those color coded. We can quickly match again T to G, so angle G here. In blue, we had P and K. So this would be a K. And then in green, we said that N went with R. So N went with angle R. Now let's just be careful about our sides here. So TP, so the first two, inside TP, that's going from red down to blue here. See that? So we're going to go from red to blue. T to P, G to K. Again, red to blue. So I want red to blue, G, K. All right, now for the next one, let's highlight this one. We're talking about PN. So from P to N, we're going down here on the bottom. We're going from this corner to this corner. So from P to N, it's the same as seeing K to R. K to R. And again, from P to N, we went this way, blue to green. So I got to go from the right angle. That's why we're saying KR. All right, and then TN, we're going kind of down that slopey side, if you will. So from T over to N, that means we're going to go from G over to R. So we want GR here. Okay. So we've got our corresponding angles and our corresponding sides. We can see which angles match up and which sides match up. And now I've got it here already for you. In case you forgot this from elementary school, triangles add up to 180. We can see here we got 60 plus 30. That's 90 degrees. 60 plus 30 is 90. And then 90 plus the other 90 here is where I get the 180. So triangles always add up to 180. And I wanted you to go ahead and have that in your notes. That's a fact that we're going to kind of continue to remember for the next couple of units. All right, and now for our last example on this page, we actually see a similar shape within the other shape. So imagine if I were to take this, see how I can just kind of scooch this out a little bit? Imagine that shape just gets enlarged, and that's how it's now the red one. Okay, so basically you can think of it as the red one getting shrunk down, or you could think of it as this blue one getting enlarged up. It doesn't matter. But what I'm going to do is I'm actually just going to take this shape and I'm going to just drag it out. So the blue here you can see, and I'm just going to label it BOT. And then I'm just going to copy and paste it. This is congruent. I'm going to change the color to a red one. And I'm going to take that congruent shape and I'm just going to enlarge it a little bit. So see how now it's that one? So these are similar figures. Here's an A, and then this is O, and then this is C. And of course I can take something that's similar and kind of nestle it inside like this one. And that's me kind of recreating the picture that you see there in your notes. So far in the notes, we've seen them two side by side like this. And this is the first example where you can kind of see it kind of embedded within the other shape. But it doesn't really matter. As long as you got your similarity statement, which we do, we should be good. So B matches with A. And you can see that here, that B is in the same spot as A. So B is in the same spot as angle A. So this angle right here is the same as this angle right here. Now O up top is the same letter that we use for both of them, because if I'm just going to move this triangle into this one, I can just keep letter O for that. I could just keep letter O. So O matches up with O. And then T over here, T matches up down here with C. And you can see that over here that T is in the same spot as C. All right. Now if we're talking about this side over here in green, B to O, then we're talking about this side, A to O. All right. And again, BO is right here, and then AO is right there. Now if I want OT, I'm talking about this side. So OT got larger to be OC. And then the bottom line here, so from B to T is now down here A to C. Also, if you want to take the two shapes and kind of draw them side by side, that's certainly fair game. Not everybody needs to. Some of us can certainly look here and say, okay, so like this side B to O is this side A to O. Okay. All right, now that takes care of the notes for pages 1 and 2, and you're getting ready to work on page 3 on your own. A couple of hints and special tips for page 3 real quick though before I stop this video. So for page 3, up at the top, you're trying to find a pair of congruent figures, and remember congruent is back to being the exact same. So for this one right here, these 1, 2, 3, 4, 5 shapes, they're congruent to these 5 letters down here. If I try to match this up with this one, you can see this one is not the same shape. That is not the same shape. Okay, so 1 does not match up here with I. It's not L or E or A, but it's W. If I take W, see how if I just turn the shape a little bit, that is it right there. So 1 matches up with a W. 1 matches up with a W. And what that means for the puzzle part is that down here, since we just did number 1, and we said it matched up with W, I'm going to put a W right here for number 1. Okay? So basically for this top part, you're just trying to match up. We took care that 1 matches with W. You now have got to match 2, 3, 4, and 5 with these letters. And then I'm going to actually do just a couple from this section with you. Okay. I'm just going to do number 12 so you see how to answer it. And I'm going to do number 17 so you see how to answer it. After I get done explaining 12 and 17, then you're just going to finish this page on your own and fill out the Google form. All right, so for this one right here, we're seeing that SKM is congruent to NGJ. So S and N should be in the same spot. So if this is S, it's the same as this N right here. Okay. K in red is the same as G in red right there in the middle. And then M is last and so is J. So M and J are the same thing that go together. So for the first one, it wants to know what side matches up with SK. So SK, if I look at my similarity statement, SK is NG. Okay. Now over here, I just matched number 12 with NG. So over here, I'm looking, here it is. So see how number 12, there's its answer, which means I'm going to fill in with letter A. So 12, I matched up its side. I found it over here, so now I'm going to fill in the puzzle with a letter A. So 12 is right here. There's a letter A. All right, I mentioned that I would do another one. Let's look at number 17 here. It wants to know what angle is the same as angle M. So M is the last one, so J is the last one, so angle J. So over here, I'm looking for the answer. I see angle J right here is my answer. So since I matched it up, I now know what letter to fill in for the puzzle. It's going to be this letter S. So number 17 matches letter S. So I'm going to find 17. Here it is. So that's how the puzzle sheet works. I know in your packet, you can see that the number down here got cut off for number 3. That's page 3 that we're on right here. So that's the end of this video. And right now you're going to be working on this page 3. And there is a Google form for you to submit on Schoology when you're done. Okay, don't forget to submit your Google form. Thank you for watching.